Good afternoon, my fabulous chemistry students. Video number 8, Lewis dot diagrams. There is another model. We will use a model that shows just the valence or outermost electrons. This is going to help us because when I deal with atoms, you'll find that most of their properties, reactivity, chemical properties, have to do with how many just valence shell electrons we have. So we are going to do just the valence electrons, okay? In this, then we're going to start with the symbol, and then we are going to draw in the number of valence electrons. But let's get a little bit deeper here. How about if we're going to do nitrogen, my symbol would be N, okay? And if I look at my periodic table, I have a electron configuration of 2-5, and I just told you that a valence electron is the outermost electrons. So I have 5 valence electrons in nitrogen. Now, I'm not going to ask you to write that out all the time. I just did it to show you what we're looking at. So it says arrange the valence electrons first 2 together, and then if there are more, we need to go around the bus until we get to 8. So let me explain what that means. This is the way I learned to do this, and this is the way I want you to do it. Ready? First 2 go together, then 1 at the time around the bus. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now, that is how things actually work in chemistry. There's always an exception to every one of our rules. Okay, you'll find that I like to use dots, not X's. And if I follow my rule, carbon is going to look like this. Well, there's always exceptions in chemistry. You're going to find we come up with these rules and then we break them usually. This is the actual correct way to draw chemistry, but it's because these particular electrons are what we call hybridized between their orbitals. So sometimes you'll find you can go 1, 2, 3, 4, 5, 6, 7, 8. So I don't think that this way is necessarily going to be wrong, but this is the way that Mr. Milks really wants you to do it. I want to see everything done this way because that's how I teach it. Carbon is just simply an exception, if you will. So if I am dealing with ions, of course, now we have an electron issue because ions are the gaining of losing of electrons. I see here sulfur -2. To get a -2 charge, I must add 2 electrons. Okay, we will find out that if you are a negative ion, you will most likely have 8 valence electrons. So let me draw this out. I have 1, 2, 3, 4, 5, 6 electrons that were sulfurs to begin with, but they became an ion, so we gained 2 more electrons. Do you see? So now I have a total of 8. I'm going to put on my brackets and include my charge so I know that it is a ion. If I have a positive ion, to get positive, I must remove an electron. And luckily, we will find that with most positive ions, I end up with no valence electrons. Notice I still include my brackets to say I don't want many electrons back and my charge of a +1, so I know it is not a regular atom. So we have some to practice. I will do 3 and let you do the rest. I will start with silicon, which is Si. Si has a electron configuration of 284. So I am concerned just with my valence electrons, which is my outermost number in my electron configuration. I have Si 1, 2, 3, 4. Beautiful. If you give me Si 1, 2, 3, 4, as long as there's 4 valence electrons, I will most likely give you credit, but this is the one I really want to see. Copper's the one that hybridizes. Okay? Oxygen, symbol is O. I look at my handy dandy reference tables. I have 2, 6 as my electron configuration. I'm only concerned with my valence electrons, which is the last number. First 2 around the first 2 together, 1, 2. Next around the bus, so 1, 2, 3, 4, 5, 6. That is what oxygen looks like with a Lewis dot. And what is very, very helpful in something like this, we will learn on the next page. This is called a lone pair of electrons. Oxygen has 2 lone pair electrons, so we can assume that oxygen wants to make 2 bonds. Very helpful in the future. So oxygen with a -2 on my last one that I'm going to do for you guys. Symbol, of course, is still oxygen. I learned that its electron configuration is 2, 6. We also learned on the last page that we always have 8 valence electrons when I have a negative ion, and that makes sense because if I take 2 and add that to my 6, I have 2 to start, and I add 2 more to my 6, I get 8. That makes sense from what I learned on the last page. I have 8 valence electrons when I have a negative charge. I gain 2 electrons to make this a -2 charge. 6 plus 2 is 8. Everything works out. First 2 together, and around the bus, 3, 4, 5, 6, 7, 8. Am I done? No, I am not. I need to include my brackets and my charge to show that I am an ion and not an atom. And now I have done 3 of the potential types of electron dots for you. I want to see you guys do the rest, and we will see them in class. Okay. Quick note. Again, that number of unpaired valence electrons will help us determine the number of bonds it could make. Okay. When determining the number of the bonds we can form, we want to arrange them into the maximum number of unpaired electrons that we can. All right. So carbon can be arranged in either of 2 ways shown, right? I can do carbon 1, 2, 3, 4, or I can do carbon 1, 2, 3, 4, and we will find that the maximum number of unpaired electrons is how carbon exists, but that is because it hybridizes, and we are not going to go into how or why that is unless you really want to know. I will tell you that this is a lower form of energy than this, and that's how we're going to leave it. Carbon is the one exception to our Lewis dot rule that is going to plague us, but it's an okay thing. We have everything else works. Sorry about the bell. So we have practice. You have advantages of Bohr, advantages of Lewis. What is the number 3? What is the maximum number of electrons that can be in a shell? Ooh, right out of the notes. Okay, the number of bonds. Ooh, what kind of electrons am I looking for to see how many bonds I can make? And we're going to have a whole unit on bonding, so it's going to come back. Okay, an atom, which of the following will form the most bonds? So I need to be able to know how to do 4 to do 5, and guess what? They are all in the notes for us, which is a wonderful thing. So now we can use the periodic table to not just define our electron configuration, but we can use that electron configuration to figure out our valence electrons, which we will show around our symbol to make a Lewis dot diagram, which will be the most often way to represent atoms that we do. See you guys tomorrow in class.